So guys, can you hear me?
Yes.
Yes.
Yes,
Yes.
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 So let's begin. I think that's 7 people. I think that's fine. So Felipe is not here, but he's recording the meeting. So after we can watch and show to other people if we need. So let's begin this tech session today. It's about machine learning and TensorFlow. This is part of my internship here at FAIR. And I'm going to talk about TensorFlow. TensorFlow is a Google library using to deploy machine learning models. So this is a code-based tutorial, a kind of tutorial. So we're going to see how to work with TensorFlow in a very practical way. So just talking about myself, my name is Hugo Zanini, and I'm going to talk about machine learning. If you have some questions, some topics to discuss, just message me at hugo.zanini@faircg.com. So yeah, let's start talking about some popular uses and what's machine learning and where it's used. So for me, the best definition about machine learning is to give the computer the ability to learn without being explicitly programmed. So that's basically how machine learning works. So we are going to say to the computer, oh, you have these rules and you have to learn something using these rules. And I'd like to start just talking about a very famous example. Probably you have like faced it in your life. That's about Instagram advertising campaigns. If you use Instagram, you have noticed that all advertising that you see is related with the page that you like. For example, I really like soccer. I'm Brazilian. So everything that I see in Instagram is like soccer players and soccer page. And all my advertisements are about like beers and soccer and t-shirts, balls, this kind of thing. And when I was preparing this tutorial, I decided to test the Instagram algorithm. So I went to a woman's bag Instagram and I liked a lot of photos about bags. And 2 seconds after, when I refreshed my Instagram, I was seeing a lot of women like advertisements, and I was seeing like shoes and bags and this kind of thing. So this is machine learning. This is what Instagram is doing. It's like analyzing our data, put each user in a cluster, and providing advertising for these clusters. So this is pretty basic and it's pretty useful. Probably Instagram is doing a lot of money with it, and they have other people doing the same, like Google is doing the same, Facebook. They are basically analyzing our data and generating models to provide some predictions and personalized advertising. But this tutorial, this tech session, we based in pattern recognition in image. So I'd like to give another example about Airbnb. I don't know if you are Airbnb users, but Airbnb tried to recognize patterns in each image that the users provide to the site to see if these images are good or try to categorize as well. Because think, if a user put like an image of a living room, and after that an image of a kitchen, and an image of a bedroom, and after that a kitchen again, when someone is going to try to, I don't know, rent some apartment or some flat, he's going to see a lot of random photos and it's not good for the user experience. So what Airbnb do? He tries to recognize pattern in this image to say that image it's a living room, that image it's a kitchen. So we're gonna put these images together to make the experience better. And besides that, Airbnb tried to validate the image as well. For example, if the user puts this image and say, oh, this is a bedroom image, and that's okay, this is true. But if the user put like this taller image, probably it's not a bedroom image. So it says, oh, it's not a bedroom image. Then to try to put something like better that my users can see. So that's how Airbnb works, and they are just recognizing pattern in the image and providing an output. So this is what we are going to do in this tech session. But before we went to the code itself and the technical things, I'd like just to say why do you need machine learning? So the problem, the big problem nowadays is like data is growing a lot. So more than 8% of internet data is structured. So we have videos, photos, documents, and graphs. And why this is a problem? Because imagine, for us humans, it's pretty easy to recognize patterns in small amounts of data. Imagine that you have like a table with, I don't know, 5 rows and 5 columns. You can go through this data, look what's happened, recognize some pattern. But if you have a big table, or if you have a lot of text files and you have to go through each one of these files or each one of these rows of a table and try to identify something can be very difficult. So that's what machine learning is going to do for us, because we're going to teach the machine these rules, what the machine has to identify, and they're going to let the machine, I don't know, hours, maybe months doing this kind of job, and they're not going to be tired because they are machines and they have this power of scalability. So they can recognize these patterns and say to us, oh, this is what's happening in this data, this is what you have to do. So now explain how it's going to work. So imagine we have the following problem. We have 10 digits from 0 to 9. This is handwriting digits. So someone writes with their hands. And we are going to try to identify which digits are they. So for example, if I pass this number 1, I want the computer showed me that this is a number 1. If I pass this number 2, the same thing. But here we have a big problem because different people wrote different numbers. So for example, this number 1 is different of this number 1, that's different of this number 1. So it can get very complicated because think in a programming way, like in a traditional way. If we would like to recognize these patterns, we'd like to say to the computer, oh, this is a number 1, this is a number 1, this is a number 1. Every time that you see some one of these patterns, you have to give this output for me. To make it more clear, which is a number? So a number is a matrix of a lot of values, and each number has different matrix. I access this number 1 using my code to see what it represents. So this is very strange matrix with a lot of values. And imagine if you have like this number 1, but will be one matrix. This number 1, a different matrix. So it can get very complicated. And imagine if you're going to do a lot of ifs. If you see this number 1 is this matrix. If you see a different number 1, it's going to be another matrix. And it can have a lot of codes, a lot of things like that's not possible to work in this way. So what we're going to do, we're going to change the rules because thinking in a traditional programming logic, we have like the rules, the ifs, we have the data, like the matrix with the numbers, and you have the answers. So for example, if I create a lot of ifs and I put a specific number 1, I'm going to have the answer, oh, this is a number 1 because I analyzed a if. But in machine learning, we're going to do the opposite. We're going to provide the answers. We're going to say, oh, this is a number 1. This matrix represents a number 1. This is the data. Give me the rule. What I have to do to identify that this matrix, we're going to be a number 1. Did you get it? It's like what machine learning is going to do. It's like just generate these rules and create a model. So this phase of provide the answers and the data and get the rules is called training phase. So they're going to provide a lot of data with a lot of labels and a lot of answers, and we're going to try to generate a model. So probably you have seen this image, it's pretty famous. This is a model. This is a group of functions that are going to try to predict the rules. The rules are inside each one of these dots. So we have the data, we have the rules, and we have the prediction. This is called a model, and we have this what's called inference phase. So thinking that way, we have the data and we have the predictions, and when you have these predictions, we are going to compare with the correct answer to see if this model is good. I think it's not very clear here. I'm going to try to show it in a better image. So think, here we have a lot of numbers, like thinking the same problem. That's going to be the data. And the data is going to the algorithm where we have the model who's going to do a prediction. And we're going to compare this prediction with the correct value, like the answer that we provide here. And if this answer is good, we are going to deploy the model. Otherwise, we're going to do a hyperparameter optimization and try to train the model again. So machine learning is an interactive technique. So we have to run it a lot of times, like looking at the predictions, looking at the correct values, and trying to make this model better. So I have a code here that I did in Colab. I'm going to share with you. You can access if you want as well. You don't have to install anything. Just open and you can see what I'm doing here. So I'm just going to put the model to run while I explain because it takes some time. And after that, we come back here. Good. So how I said, we have to generate a model. So we always going to have an input and an output. And between this input and output, we have a model, my head model. So this input always, in our case, is going to be an image. So in that case, it has a lot of numbers image, and each image has a shape of 28 by 28. It's this. So for example, number 1 again, we have this matrix with 28 rows and 28 columns. So because of that, I define the input as 28 by 28. And the output of my model is going to be 10 values because we have like values from 0 to 9. So 10 different values. And every machine learning model who is doing classification, we're going to have multiple outputs. This is the output of the model. So what is each one of these columns are probabilities. So for example, I put an input, in that case I put a number 4, and this was the output of my model. So it tried to predict all classes, and at the end, the number 4 classes was the most probable. So this is going to be the answer of my model. So because of that, you have 10 different outputs, and you're going to see the most probable one, and you're going to choose this. So I think that's pretty clear, pretty easy. Input, output. This is made in TensorFlow, so it's how it's going to work like in a programming way. But we have this middle layer, these 128 things. So let's explore what is this. I'm going to do a basic pipeline here just to make it clear for you. So we have the input, in that case 28 by 28. And we're going to connect this input to a box. This box is going to be the model, the 128 things. And you're going to have an output as well, but I'm going to explore it after. So imagine that these 128 things are functions. We have pretty simple functions here, like multiplications and sums, this kind of thing. And each one of these functions is going to try to predict which class this number is, which number is this one. So here we have like 28 times 28. We have 784 values, 784 pixels. So imagine we're going to take this first pixel, this first one, and we're going to pass this pixel through all these functions, function 1, 2, until function 128. And each one of these functions is going to say for me, oh, I think this first pixel is a number 1 pixel. And the function 2 is going to say, oh, I think it's a number 1 pixel as well. But function, I don't know, 127 can say, I'm not sure. I think this pixel is like number 4. So these functions are going to analyze all pixels and provide 10 outputs for all pixels. And it's going to get like quite complex because you're going to have like 10 outputs for this first function, 10 outputs for the second function, and we are going to have it like 784 times. So we are going to have a lot of outputs. And how are we going to discover which output is better? Using statistics. So we are going to analyze all these outputs, and we are going to say, oh, this output was more frequent, so probably this is, in that case, number 1. So for each function, we are going to have like 10 outputs. In that case, we have like number 1. So number 1 was the most probable. But if you see to the other outputs, you have some values here as well. For example, here, number 10 was almost 10%, number 3 as well. But number 1 was the most probable, like 8%. So we are going to choose this input, this output as the correct one. So to do these statistical things, we are going to use a logistic function. I'm not going to explain this function because it can get complex. But yeah, we're going to have this function, and we're going to analyze all these outputs of each one of these functions 784 times, and you're going to have the prediction. So this is how we teach these rules to the model. So the model, we are going to try it a lot of times, like each time that the model analyzes all these pixels and provide all these inputs, it's called epoch. Usually we run it a lot of epochs to get the result. And at the end, we're going to have a good model that when you pass a totally new image, they're going to be able to predict. I think at the first time can be complex to understand all these concepts, but if you go through like thinking pixel by pixel, I think it's pretty easy to get the concept. So I think now this image can be more easy, can be easier to understand. So imagine you have the data, you have the numbers here. Let's think in number one again. You have number one, and you're going to train your machine learning algorithm, that is this part, and you're going to have a prediction here, a value. And we are going to use this value to compare with the input. So is this value good? What happened? And if it's good, we are going to deploy the model. Otherwise, we are going to do a hyperparameter tuning and try to change these values of the functions to make the prediction better. So that's it. So trying to explain it, like imagine if you are going to sell your model, you are going to sell your job. So how can you give like more complex names to these things? So each one of these functions, outputs, and this logistic function, we're going to be called neurons. So we're going to see I have a model with a lot of neurons, and all these package of neurons, functions, inputs, outputs, are going to be called machine learning or artificial intelligence. So that's how it's going to work and how it's going to be. So in this case, it was simple. I'm not going to say that machine learning is simple and easy to understand, because when you have like a lot of data and more complicated things, can be very hard to work with. But yeah, if you are thinking like in a just pattern recognition in image, it's pretty simple, just this model doing the job for you. So now back into the code and showing what happened. So how I said, I think this part is clear, like the input, the output, and the middle layer, the functions, what you have to do. But we have to optimize this model as well. How I said, we have to take the outputs, compare with the true values, and say if it's accurate or no, what happened, and who is going to do this comparison. The function in charge of this step is called loss function. So what the loss function is going to do, it's like looking at the outputs, looking to the correct, the desired output, and say, oh, this output is good, or this output is bad. And with these values, this loss function is going to say to this optimizer, oh, go back to the code, go back to the model, and try to change the function's parameters to make the output better. So this optimizer, we're going to change, we're going to put like different values, usually random values, and we are going to change the output. This optimizer has a lot of parameters to be choose, you know, like learning height, for example. How big will be this change in the values? It will be like 0.0001, 0.003, and you have to say a lot of things to this optimizer to improve your model. And okay, but we are going to do it a lot of times until achieve a good result. How I said, machine learning is a big four. It's like a lot of things running over the time, and you have to changing these parameters to make it like work for you. So to make it, we're going to have this piece of code where we pass our train image, our train labels, and our epochs. In that case, I define 20 epochs because it's more than enough for this kind of problem. And we're going to run it 20 times. This loss function is saying, oh, it's good, it's bad. the optimizer, it's like trying to change the functions parameters, and at the end, probably gonna achieve a good result. So I put the model to run here. So if you can see, this problem is pretty easy. So at the beginning, we have like 0.99% of accuracy. And yeah, I trained for 20 times. And here it's the result of the model. So for example, I put a number 4. If you can see, it's not a very good input. And here's the prediction. He tried to predict number 1, but number 4 was the biggest output. So probably it's a number 4. And I did it with a lot of numbers. So number 7, number 2. Some numbers it's more difficult, like this one. I don't know if it's number 8 or number 5. Even for me, it's difficult. But the algorithm predicted well, like was number 5, and tried to predict number 6 as well. So I'm not going to explain the alt code because the most difficult part was this one that I showed you. The other part is just data processing and show image on the screen. But this is pretty basic and good to work with. So you can go through this code after and see what's going to happen. And if you have some questions, just reach me on Slack and email. That's fine. So guys, that's it about machine learning. I think I try to be as brief as possible and make everything clear. I hope you enjoy this brief explanation. And now I'm going to talk about the main machine learning libraries. So I'm programming Python most of the time. When we are working with machine learning, we are programming in Python or R. So the most important library is called TensorFlow. That's the library that we are using here. This is a Google library. It became open source in 2015, and it was game changing because it allows us to go deep in the code and understand what happened in the layers, and it's pretty nice to work with. We have PyTorch as well. PyTorch is a Facebook library. It's open source as well, but for me the syntax is more complex, not too easy to work, and I prefer TensorFlow. And we have Keras. Keras, it's a TensorFlow based library, and it's a higher level library. So if you notice, in the code, they are using Keras, not TensorFlow, because you're not going to deep. The syntax of TensorFlow is more complex than Keras. So sometimes it's better to use Keras, but at the end of the day, it's the same thing. If you need to change some more specific parameter, use TensorFlow. If you're just operating the high level, use Keras. So here we have Python and Jupyter. Python is like the language. Jupyter is the most important IDE to work with. So you can open your browser. It's like Google Colab, but for me it's better. And I really like Jupyter. And we have NumPy and SciPy. There are mathematical libraries that you have to use if you need to work with some statistical things, mostly the optimization part. During my project here at FAIR, I use a lot of tools in SciPy to do a Bayesian optimization with the model. If you are interested in what I did, you can go to the documentation and Confluence, just search for IMML, and explain in a very simple way how I did this optimization, how I use SciPy. And you can go in the code as well, on Bitbucket, IMML FAIR, and you can see what I did. So now talking about automatic machine learning. Automatic machine learning is a very good approach to work with because it's like a big black box. You just put in this model your input, and it's going to give you an output. And you don't know how they did the optimization or which model was used, but it's pretty useful, mostly when you are start with machine learning. I started work with HEO. Okay, I started to work with HEO like 2 years ago, and it was very good to understand the power of machine learning. But when you start to work with more complex systems, it's very important to know TensorFlow and PyTorch. But I really recommend HEO and go to the documentation and explore the features. And we have AutoScaLearn as well. It's good, but HEO is much better, and I really recommend it. So now talking about some materials, some things, if you want to go deep and understand better machine learning. Now, I know it's 30 minutes, it's like such a little time to talk about machine learning and try to pass a very good knowledge. but I highly recommend this book, Hands-on Machine Learning with Scikit and TensorFlow. Actually, this is the book. I really use this book like to work every day and see what's happening. And so, how I said, machine learning is complex, so sometimes you have to review the concept and try to keep your mind what's going on. So I really recommend this book. These are the one. It's good as well if you are starting with Python and you want to know more how to build the algorithms. You can use this book. Here we have some courses. This course is amazing. It's amazing. It takes time, around 3 months, to complete the whole specialization. But if you are interested in working with machine learning, it's so good. Andrews is like really nice teacher. And these other two links are some links that I use it like on a daily basis as well. Sometimes I need to review some concepts, so I use it to go to these Geoffrey classes. It's a kind of old material, but it's so nice. And these YouTube playlists, like if you want to review some concept, like very short, just to remind, it's very nice and very good to go through as well. So guys, that's it. If you have any question, anything, that's the moment to ask. Thank you.
Thank you.
So, Hugo, I mean, I've got a question, Matt here. So what's the best approach to get into this then? Read the book or learn Python or do a Udemy course? Or it's like, how did you get into machine learning? Like, if you're, let's say, you don't want to become an expert in it, but you just want to like try it out. Right?
Okay. Oh, so personally, like talking, I really like this book. It's like pretty basic. Start with some basic things in Python and machine learning as well. So I really recommend this to start with. But if you is the kind of guy who prefer like some online material or some course, just go through this link. You can have all the resources here and Python things in the beginning, like the baby steps. This course, we're gonna cover everything. So if you prefer books, this one, and if you prefer courses, this specialization is like amazing.
And if you're saying 3 months to complete, is that like full time or like in the evenings or?
It's like a lot of course. So you can do like the first one in, I think, 2 weeks with 7 hours per week, something like that. They have a kind of schedule so you can see and how you can go. But yeah, it requires time, like at least 5-7 hours per week to complete the whole specialization in 3 months.
Right. Okay. And if I just want to be a software developer, I just use a library and train a model and run it on some data. I guess I don't need to really understand how machine learning works, or is that a false assumption?
Yeah, how I said, if you want to just run the model, you can use machine learning, automatic machine learning, and it's going to solve your problems, you know? Just go through the HTO documentation. It's pretty easy to work with, and it's the best approach to start. But if you really want to be a machine learning engineer and optimize the models, it's good to do this kind of course. But in HTO documentation, I think in 10 minutes you can start to run your first model. But it's a big black box. You don't know what's going on.
Okay. Cool.
Anything else, guys?
Good.
All good?
Yep.
Thanks.
Nice.
Thank you very much.
Thanks a lot for the insightful.
Thank you, Hugo.
That was very
Thank
good.
you, guys. Very good.
Thanks, Hugo.
Hope you enjoy. Thank you.
You can share the slides and the video. It will be great.
Yes. Felipe is gonna upload it during this night, so everything is gonna be available for you.
Awesome.
Excellent. Thank you.
Cool.
Thank you, guys. Have a good day.
Thank you.
Thanks.
Thank you.
Bye.
Yes, bye.
Bye.